Dumelang. In classwork 1, we were given -3, -1, 1, and 3. The first question wants us to determine the general term or rule, or the nth term. We need to find the value of the 11th term, and we need to determine which value will be equal to 21. I will start with using the formula. You need to remember that term 1, which is A, is -3. Term 2 is -1, and term 3 will be 1. When you study this pattern, you will notice that you keep on adding, right? To move to the next term, you keep on adding. Question is, how much are you adding? We know that you need to use this formula. And to determine how much you're adding, you will just say -1 minus -3. And you will notice that you keep on adding 2 to get to the next value or to the next term. And that is D. Now, to determine D, you will just take -1, which is term 2, minus -3, which is term 1. And when you calculate that, it will give you a common difference, which is 2, because we keep on adding 2. Where there is A, you will substitute -3. Where there is D, you will substitute 2. Then you will have to multiply out. When you multiply out, you will multiply everything by this 2 over here. So 2 times n will give you 2n, and 2 times -1 will give you -2. You will end up having -3 plus 2n minus 2. And these here are like terms. You can therefore add them, -3 and -2. That will give you -5. So you can't add 2n to all of them because 2n doesn't look like them. It's not like with them, and hence 2n will remain the same. And this is the general term that you can use to calculate the value of any given position, or the value of the term given the position, where n is the position and Tn is the value of the position. Now, to determine the 11th term, it means n is equal to 11. You will go back to the general term, and wherever there's n, you will substitute 11, and you'll end up having T11 is equals to 2 times 11. 2 times 11 is 22. 22 minus 5 will give you 17. This means that in the 11th position, the value of the term will be 17. Okay, which term will be equal to 21? Here, note that you are given Tn is equals to 21. You go back to the general term. Where there is Tn now, you are going to substitute. So this is the general term here, where there is Tn, you will now substitute 21. And when you substitute 21, where there is Tn, you will end up having 21 is equals to 2n minus 5, transpose 5, and take it to the left-hand side, it will become positive, all right? So you will end up having 21 plus 5, which is 26. And then you divide both sides by 2, you will end up having 13 is equal to n. For classwork 2, we need to answer this question. I started first by finding the general term using this method here, where we have Tn is equals to dn plus c. Tn is equal to dn plus c, where d is the common difference. Now study the pattern and you will notice that in this pattern here, to move to the next term, you keep on adding, you keep on minusing 5, you keep on subtracting 5. So D will be -5. And for you to get the value of C, C is the term before the first term. Now, if I subtract when moving to the next term, if I was to go back, I will keep on adding, right? Now, I'll just show you the Nice way of doing it. Now, here I have this. I do have D, which is a common difference, and that is -5. You get it by taking term 2 minus term 1. 20 minus 25 will give you -5. To get C, guys, you will take term 1 and add the common difference. But you only add the common difference if the common difference is negative. If the common difference is positive, to get C, you minus the common difference from the first term. Now here I will take 25 and add it with 5, and that will give me 30. So where there is C, I will substitute 30, and where there is D, I will substitute -5. That's it. And the rest is pretty much the same as what we have done. This is what you will get if you were to use the general term formula. Please note that Tn here is -45. So where there is Tn, you go back to the original general term. Where there is Tn, you substitute -45, transpose 30 to the left-hand side. It was positive. It will now become negative. -45 minus 30 will give you -75. And divide both sides by -5, and that will give you n equals to 15. I always emphasize this. Note that n cannot be negative. N cannot be a decimal. N cannot be a fraction. It must be a natural number. Try this one out. And here, for me to get C, because I keep on adding 6, to get C, I will say 5 minus 6. 5 minus 6, because my common difference is positive, and C will be -1. See? Whereas D, you substitute that 6, which is a common difference. Or you use these general term formula. Here, D is 4, C is 2. So you'll have 4n plus 2. See? Easy. Here, D is 4 and C will be -1. So it's 4n minus 1. Here, D is +6. So C will be -7 minus 6, which is -13. So I'll have 6n minus 13. We've got common difference here. It's actually negative, and it'll be -3. So you'll have 18 plus 3 is 21. I'll have -3n plus 21 as the general term. This one here is actually incorrect. I substituted -3 where there is D, and that was supposed to be -13. And now it is correct. And obviously it'll change everything here. Instead of having -3 there, I'm supposed to have -13. I bet actually, I keep on confusing this with another one. I thought that was 47 and not 57. Everything actually is indeed correct. Everything is actually correct here. My bad, my bad. I'm confusing with the one that we did earlier on where I had 60 and -47. Here it's 57 and everything will be correct. Here, please note that the first pattern has 3 sticks and the second one will have 5. And the pattern here is that you keep on adding 2 to move to the next one, which is arithmetic. And these will be the solutions. In the next video, we'll be doing geometric sequence. Now, what differentiates the geometric sequence from an arithmetic sequence is that a geometric sequence requires you to multiply or divide to move to the next term, or else arithmetic sequence requires you to add or subtract a common number or common value, which we call a common difference. Here, you add or actually you multiply or you divide by a common ratio. You multiply or divide by a common ratio. That is what differentiates a geometric sequence to an arithmetic sequence. All right, please check out the next video as we go into this in detail. Thank you for watching. Do not forget to like and subscribe and hit the notification button. Kgotso.